right, so law of sines. Has anyone ever heard of that before? Yes, we've heard of at least the formula kind of thing. Okay, if we had Pythagorean theorem for like right triangles, we're able to find like the third side length, right? Or we're able to use trig to find the missing angles, but it has to be a right triangle for that. Law of sines allows us to find side measures or angle measures for any triangle that we're given, okay? The formula for law of sines is right here. We have A over sine of A is equal to B over sine of B is equal to C over sine of C. So if we're given some of that information, we have three different proportions we can set up and solve using cross products, right? Cross multiplication there. Notice you can also, I usually write it like in the reverse order. I like to write it with the sine of the angles on top and then the side lengths on bottom, which let's go ahead and just write that down here. The little A, B, and C, these are all sides. Actually, I'm just going to underline it. Those are your side lengths. And then the capital A, B, and C, those are our angle measures, okay? So if you see a capital letter, that usually denotes your angle. If you see a lowercase letter, that denotes your side. Okay, so if I'm going to draw a little triangle here and kind of show you how this formula was created. It's not like you have to like actually have this memorized of how this works, but I'm just going to show you, okay? This works for, again, any triangle that you're given. So let's call this side or angle A, B, and C. When we're labeling the side of the triangle, we always use the lowercase letter of the opposite angle. So if my angle A is here, side length A is going to be right across from that. Side length B is always across from angle B, so B is over here. And side length C is across from angle C. Okay, so if I were to draw in this dashed line here and call this my height of that triangle, it's also called our altitude. This is how this formula was kind of came to be. So let's say I wanted to know what sine of A is in terms of A, B, C, and H. Sine of A, looking from A, what's the opposite side? Again, in my right triangle, we have to have a right triangle here if I'm looking for sine of an angle. So sine of A would be H over C. Do we agree? Okay. If I was looking at C, looking at my right triangle here, ignoring that other half, sine of C would equal opposite over hypotenuse, which would be H over A. Okay, if I solved both of these equations for H, this becomes A times sine of C is equal to H. And this top one becomes C times sine of A is equal to H. Now, using our algebra skills, what could I do from here? Set them equal to each other. So I would have A sine of C is equal to C sine of A. Now, the way they make these proportions really nice, looking over there on the left boxed in red, is if I divided both of these sides by A, those go away, right? And then if I divide both sides by C, the C's go away, and then I'm left with my proportion of sine C over C is equal to sine of A over A. So this is where that formula comes from, is by doing some trig with our right triangles. And then, again, it's the same thing for sine of B, but I'm not going to do that one as well. I just wanted you guys to kind of see where it came from there, okay? So you're going to be given this formula on your quizzes and tests. You just have to be able to use it to find out your missing side lengths and angles, okay? So first triangle here is that ABC is that A is 32 degrees, B is 81.8, and side length A is 42.9. So first thing we want to do is draw ourselves a little triangle. And I'm going to label these side lengths. A, B, C. Okay, this is obviously not an equilateral triangle, so this is not drawn to scale, FYI. But I can just label the information in here that I know. A is 32 degrees. B is 81.8 degrees. And then side length A is 42.9. So that's going to be right across from angle A. So 42.9 centimeters goes right there. Were you okay with the placements of all those things? Okay, so now we can just use my proportion. I'm going to set up all three of those fractions there, and then I'm going to solve for the missing pieces. Before I do that, however, could I solve for the missing angle right here? Yeah, what is 180 minus 32 minus 81.8 going to give me? 66.2 degrees. Very good. So let's go ahead, set up my proportion. Again, I like to write the signs on top. That's just personal preference, but you don't have to. You can write them on the bottom if you would like, okay? So I've got here the sine of angle A, which is 32, divided by the side length of A, which is 42.9, is going to be equal to sine of B, which is 81.8, divided by, I don't know the side length of B, and then sine of 66.2, all divided by side length C. So I've got three fractions there set equal to each other. I've got two unknowns. So I'm going to start by solving for one of my unknowns. If I want to solve for B, which two equations did I set equal to each other?
The left one and the middle.
Yeah, the left one and the middle one. So I'm going to select these two, and I'm going to solve it using cross multiplication, right? So if I solve this here, this becomes B times sine of 32, and then cross multiply 42.9 times sine of 81.8. And now when we are solving this, can I just like cross sine out on both sides? No. Sine of a number is a number. We can't just get rid of the sine piece. Okay, so I need to divide both sides by sine of 32 to get rid of that, so I can have B by itself. Now on our calculator, we're going to type in that whole fraction. Make sure we're in what mode? Degrees, because we're in degrees here. And make sure we're being careful when we're typing this in, because it always starts with one parentheses there and it doesn't end it. So if you don't type the fraction bar in first, make sure you put an end parentheses there as well before you divide. But everyone double check on your calculator. You should get approximately 80.128 centimeters. Plug that in your calculator and check to make sure you got that. And now if I want to solve for C, I'm going to take the first equation, this first fraction, and set that equal to my last fraction there, and just cross multiply and solve for C. So I would have C times sine of 32 is equal to 42.9 times sine of 66.2. Okay, just cross multiplying that. Okay, how am I going to get C by itself? Divide by sine of 32. So if I plug this whole fraction in, you should get approximately 74.071 centimeters. This next one here is basically the same thing, except for you've got a little picture diagram here, a little bit of a word problem. A surveyor wishes to measure the distance across a river, and she determines that the following information is given. It's also measured on the picture as well, and we only want to find the distance A. So I don't actually have to find all the missing pieces of this triangle. I just need to solve for A. So if I look at this picture here, we're given two angles. We're given a side length. Okay. We don't know what angle B is equal to, but could I find it? Yeah, take 180, subtract 31.1, subtract 112.9, and we end up getting that angle B should equal 36 degrees. Okay, so I'm going to go ahead and set up my proportions here, starting with angle A. So I've got sine of 31.1 divided by, I don't know the side length, so just divide it by A. A is going to equal sine of my B value, which we just found was 36 degrees, and divide that by, we do know the side length, of 347.6. And that equals sine of big C here, which is 112.9, divided by side length of C. Are we okay with the setup of that proportion? Yeah? And so now if I just want to solve for A, which two fractions am I going to set equal to each other and solve? The first two, right? So if I set these first two fractions equal to each other, we can cross multiply and solve for A. So this becomes A sine of 36 is equal to 347.6 times sine of 31.1. Make sure when you're multiplying on your calculator that you type the 347.6 before your sine value. Otherwise, when you type it after, it might also include it in the sine function. And then if I want to get A by itself, I'm just going to go ahead and divide both sides by sine of 36. And my distance A here should approximately be 305.464 feet. I don't need to solve for anything else because it just asked us to find distance A. So we are done. Any questions on that one? So one other thing we're going to talk about here before I give you a little bit of time to work on your homework for this first part, before I talk about the ambiguous case, is the different kind of triangles that you're going to see, okay? So if you think back to geometry, we had some congruency statements. Side, side, side. Do we remember that? If we have a triangle and I'm given 3 numbers for my side lengths, that's a side, side, side kind of congruency there. What's another one? What is it? ASA. So that would look like this. You have an angle followed by a side length followed by another immediate angle. What else is there? Side, angle, side. So you're given a side with an angle included and a side. And what can we not have? The naughty postulate. Yeah, that's right. ASS, right? It's going to say that on your homework a few times, okay? So those ones, usually I write it SSA on the answer key. It says it just straight up. It says that word right up on there. I know. But the reason for that is, if you think about it, side angle, if I have 2 side lengths, okay, followed by an angle that we have to have, say this is, I don't know, 40 degrees or whatever, there's no saying that this side length has to be right there. It could be like a little bit further in like this. It could be a little further out like this, right? This right here is our ambiguous case. Okay? The rest of these up here, these are not ambiguous because we know what's going to happen. We know what the triangle should look like. For our SSA kind of triangles, there could be more than one option of what our triangle looks like. Okay? Which means we're not going to have just one answer like we have for these problems here. Both of these problems are one of these non-ambiguous cases. Like if I look up here, I have an angle, I have a side, I have an angle. Angle, side, angle, that's a non-ambiguous case. So we only have one answer. For these ambiguous cases, it's going to be like, we could have no answer, we could have 2 answers, or we could have 1 answer, okay? And I'm going to show you what that looks like on the next page here after I give you guys a little bit of time to work on the first part of the homework, okay? So I'm going to give you guys about 10, 12 minutes right now to work on the first 2 pages of the homework, okay? There are some problems that you can cross out, so make sure you cross those out. And then, I was going to do one example of like on your homework for this first part, you're going to tell me whether it's not ambiguous or ambiguous. So let's say I gave you big A. Actually, I need to draw a triangle first. If I have this as A, B, and C, and I said, okay, we know A, we know side C, and I know angle B. Would this be an ambiguous or a not ambiguous case? It would be non-ambiguous. Specifically, which of these three cases would it be? Angle, side, angle. So that's how you're going to do those first kind of 10 problems there. Does that make sense? Cool. All right. So ambiguous case. This is when you have a triangle with an angle, side, and a side, or a side, side, and an angle right next to each other, and that's what you're given. Okay, if you're given side, side, and an angle, there could be one of three things that happens. There could be no solution. It's not possible. There could be one triangle, or there is a possibility for two separate types of triangles. I kind of draw a little picture up here on the board. If you have two of those side lengths that are the same, but then you just like move it inside instead, they're still the same side lengths, and then you have that angle down there, but you're going to have a different triangle. Do you guys agree? So you have two different possibilities of a triangle there, okay? So looking at this first one here, I'm going to draw a triangle, and I'm going to label the information that I am given to start. So I got my triangle, and I'm going to label this A, B, and C, and I'm going to label that information inside. So 55 degrees, 40 minutes, side length B is 8.94 meters, and side length A is 25.1 meters. Again, remember, make sure your side length is across from that angle when you're drawing your picture. Okay, so let's go ahead and set up my proportion here. My proportion is sine of A over side length of A, 25.1, is going to equal sine of 55 degrees, 40 minutes, divided by 8.94, is then going to equal sine of C divided by side length of C. Okay, so what variable could I solve for here first? A. If I solve for A, I'm going to set the first two fractions equal to each other, right? Okay, so I'm going to cross multiply here, and I get 8.94 times sine of A is equal to 25.1 times sine of 55 degrees and 40 minutes. Now, I don't want you to type any of this stuff into the calculator until you've solved for that variable. So how would I get sine of A by itself? Divide by 8.94. And now I have sine of A. How do I get the sine to go away? The sine inverse, right? So I would do, so A is equal to the sine inverse of this entire fraction. Okay, so I'm going to give you guys a minute right now. Try plugging that whole thing in your calculator and see what you get. There is an error. When you type this in the calculator, your calculator says error or undefined or something like that, okay? That means that we cannot have this triangle. It does not exist, okay? The reason for that is because technically if you plug in this stuff inside the parentheses and just evaluate what that equals, this is actually equal to the sine inverse of 2.318. And if you guys remember back to that page on your notes where it has ranges for what your sine values can be, what your cosine, all that other trig functions and stuff can be, the sine value has to be in between 1 and -1. So since that is bigger than 1, 2.318, I cannot take the sine inverse of that. There is no angle that's going to give me a value of 2.318 when I do the sine of that value or sine of that angle. Okay? So this triangle is not possible. So there's no possible solutions for this triangle. Okay, now we don't technically like really need to remember this interval, because if you plug it in the calculator and you get error, then that tells you right then and there that there's no possible solutions, right? But that's kind of the why behind why there's no possible solutions there. Okay, so that's one possible outcome if you have an ambiguous case. Okay, next possible outcome is if we have an angle, another side length, and another side length there. Let's see what happens for this one. I apologize, this one will take quite a bit of space, so write kind of small. Zoom in as far as you can, and you might need to move some stuff around. But my triangle here, ABC, side angle is 55.3 degrees, 22.8 feet. And then side B is 24.9 feet. Okay, so I'm going to start by setting up my proportions here. So I've got sine of A, which is 55.3, divided by side length of A, 22.8. Is going to equal your sine of B, divided 24.9, and sine of C over side length of C. So I'm missing two angles and I'm missing a side length. So I need to find all three of those pieces of information in order to solve this. Okay, what's the variable that I can solve for here first? B. So I'm going to go ahead and set these two proportions equal to each other, and we're going to solve for B. So I get 24.9 times sine of 55.3 is equal to 22.8 times sine of B. Now I want to get sine of B by itself, so what do I got to do? Divide by 22.8. And then how am I going to get rid of sine? Sine inverse. So on your calculator, you're going to type in the sine inverse of this entire fraction. We should be getting approximately 63.879 degrees. Yes? Okay. So if we think about this, I'm going to draw a little picture up here of our positive sine values. All students take calculus. This 63.879 is technically in that first quadrant there, right? Okay. Where else is our sine value positive? The second quadrant, right? So there's another possible answer for what B could equal. Your calculator just is not going to give it to you. Okay? It's only going to give you the one. So to find the other one, all you have to do is take 180 and subtract your 63.879. And when I do that, I get 116.121 degrees. So what's happening here is I could either have angle B equal 63.879, or I could have angle B equal 116.121. Okay? So I'm going to go ahead from here, and I'm going to draw two triangles. Okay, so there's going to be two options here. Triangle number one, over on the side. I'm going to make this a little smaller. And then triangle number two, over here. So triangle one, triangle two. Again, these are not drawn to scale, but I'm going to go ahead and label the information for both of these triangles before we solve for anything. So my stuff that I was given originally stays the same. So 55.3, 22.8, and 24.9. The only thing that's going to be different in these two triangles to start is that this is 63.879 degrees in this triangle. And in the other one, it's going to be 116. And if I was on Notability, I could just copy and paste all of this, but explain everything is just not as superior. Oops. 116.121. Okay, are we okay with those two triangles? Again, to find the other angle measure that it could be, we take 180 and we subtract that angle measure that we're given. So now, before we move on to find any side lengths using our law of sines, we have two angles in a triangle. Can I find the third angle? Yeah. Take 180 and subtract those values to find out what my third angle would be. We're going to take 180 and subtract the two angles that were given to find our third angle. So for here, we get 60.821. And over here, we get 8.579 degrees. We okay with that? 180 degrees in a triangle? Okay, so I have all three angles of my triangle for my two different options, okay? Because again, there could be more than one option if you have the ambiguous case. And now I just have to solve for my side C. So for both of these, I'm going to set up my proportion the same, where I'm going to use this sine of A over A. And I'm going to set that equal to sine of C over C, because we know what the angle measure is for C now, right? So I can go ahead and solve for that. So I'm going to start with triangle 1 over here. I've got sine 55.3 divided by 22.8, and I'm setting that equal to this. Oops. Where C is 60.821. Okay, and then from here we just got to solve algebra. We got to cross multiply here and get C by itself. So when I cross here, I get C times sine of 55.3 is equal to 22.8 sine of 60.821. And now how do I get C by itself? Yeah, divide by sine 55.3. So let's plug that in and see what we get. So I got 24.213, and my units for lowercase c here is going to be feet. So for my triangle number 1, I solved for side length C. I got the angle measure C, and I got the angle measure for B. So those are the three things that were unknown in that triangle. Triangle 2 is going to obviously give me a different C value for my side length because my angle measure is different for side length or angle C. So I'm going to set up my exact same proportion, except for instead of it being sine of 60 on top, it's going to be sine of 8 on top. So we've got sine 55.3 divided by 22.8 is equal to sine of 8.579, all divided by my lowercase c. We okay with that setup? And now we just got to cross multiply. I cross multiply. And then to get c by itself, I just divide by sine 55.3. and I got C to be approximately 4.137. Again, my units for side lengths for this problem is feet. So I've got my side length, that was unknown. I found my 2 angle measures. So that would be the 3 unknowns for my second triangle. So I could have 2 possible triangles here for this one example. The last example here, we're going to see that we can only have 1 triangle that comes up because we've got too many angles going on the inside. So let's start out by drawing a triangle and labeling what we know. I know my side lengths of A and C, and I know my angle A. Once we've labeled our picture, we can go ahead and set up our proportion. So our 3 fractions, we're going to have sine of 43.5 divided by 10.7 is going to equal sine of B divided by 7.2, and that's going to equal sine of C over C. Yep, this should be across. Good catch. .2. Okay, so then this is also wrong. Okay, I don't know side length B, but I do know side length C is 7.2. Okay, are we okay with the setup of those proportions? Yes, good catch. Okay, which variable should I solve for first, or which variable can I solve for? Yeah, C, right? So I'm going to set my first fraction and my last fraction equal to each other. Okay. When I do that and I cross multiply, I get 7.2 sine of 43.5. And that's going to equal 10.7 times sine of C.
How do you know which ones you
And now how do I get sine of C by itself?
divide 10?
Divide by 10.7. And now I'm solving for a capital letter, capital C, which means if I want to get C by itself, I have to do what to both sides? The inverse. So I'm going to take the inverse of all of this. So inverse sine of 7.2 sine of 43.5 divided by 10.7. I got C to be 27.593 degrees. Okay, now similar to what we just did up above, sine is also positive in that second quadrant there, which means that I'm going to take 180 and subtract that angle measure to find out what my other possible triangle would be. And I get 152.407. So now this angle C, 27.593 is option 1, right? Option 2 is that angle C is 152. If I plug in 152 here, and I also have an angle measure of 43.5, does that make sense? Can I have that? No, I cannot have 152.407 because that's going to add up to give me more than 180 degrees, and a triangle is 180 degrees. So I'm not going to be able to have an angle for B, okay? So this is when you're only going to have one case for your angle side-side scenario. So to find my other side length, or angle, sorry, I'm going to take 180 minus both of these angle measures, and and I get 108.907. So I found the missing angle measure, both of them. And now the only other thing that I need to solve for is what? Side length C. Or sorry, side length B. So, which two fractions should I set equal to each other to solve for side length B? The first and the second one. Could I technically use the third one there? Yeah, because we know what sine of C is equal to. Okay, but I'm going to use that first and that second one there. So setting both of those equal to each other is going to give me B sine of 43.5 is equal to 10.7 times sine of 108.907. What do I have to do to get B by itself? Divide by sine of 43.5. So no inverses here because we're not solving for an angle, we're solving for a side length. So when I plug this whole thing into my calculator, I get approximately 14.706, and we are in inches. So I only have one triangle possibility here. I don't have two, again, because this angle measure makes it so that my triangle is bigger than 180 degrees, and I can't have that. Okay. What questions do we have on the ambiguous case? Okay, on your homework, it's pretty much split up. That first part is just using law of sines. There is no ambiguous case. But on that second part, again, there are some problems that you're going to cross off, so make sure you cross those problems off on your homework. And then make sure you're given an ambiguous case of an angle, side, and a side, because then there's when you're going to have more than one option there for your triangles. Okay, so you guys got about 12 minutes left in class to try and get a few more of those problems done. I'll be here to answer questions if you guys have any.